Good morning or afternoon, depending on when you're taking this. We're going to do the practice check with me this time. Okay, short little video. Try to keep this short, sweet, and to the point. Again, last week we discussed a little bit about atomic number, which is again the number of protons, and the atomic mass, which is again proton and neutrons added up together. Now, one of the things to keep in mind is that what does this mean in terms of the periodic table? So today I wanted to go over that a little bit for the little check. As you can see, there's numbers at the top and bottom. The top number is the atomic number. And as you can see, that does go in order. 1, 2 is over here, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and it continues to 118. The bottom number here, for example, the 1, this is essentially 7, this is 9 essentially. That's the atomic mass, which again tells you about protons and neutrons. Well, the cool thing is, if you know the protons from the top number, and this is say 7, well, if there's 3 protons and the total mass is 7, you know that the neutrons are 4, because those two need to add up to the atomic mass. The new thing also from today that we talked about a little bit is this idea of charge. And again, a charge, it can be positive or negative. And that's going to depend, are there a lot of positives or a lot of negatives? Well, here's the thing. An ion is what we call it. An ion can have a positive or negative charge. If there's a positive charge, there's more protons, and a negative charge, there's more electrons. The big thing again is electrons are the ones that change. You can't change protons. Because if you change the protons, you change the number, you change the element. And we can agree, calcium, potassium are very different. Or, my favorite example of one thing being different, gold and mercury. Liquid, poisonous, silver in color. Gold, metal, solid, valuable, not poisonous. Really like pointing that out, which is really kind of cool thing. So one of the things I wanted to just briefly mention as well today is this idea of notation. You might see something like this in the future. And this is the first time you've seen this, so that's okay. But the top number, if you see something like this, top, bottom, is going to be the mass. The atomic number is going to be at the bottom. The symbol is still going to be in the center, and that charge is going to be the only thing to the right. Now, you're probably wondering, over here, right, the atomic number and the weight are flipped here, right? Here it's the mass. The reason we do that is because if you know the mass and the protons, to find the neutrons, all you need to do is subtract. In this case, 40 minus 20, 20 neutrons. That's the same as the protons here. So this one matches up. Here, 35 minus 17 is 18. Those didn't add up. So that's kind of a cool thing. Also, you can see this has a positive charge, calcium, over here having a positive, chlorine way over here having a negative. Well, here, the number's 20 for protons, that can change. So if you have a positive charge, you have more electrons in this case. And here you have less. So if there's 20 protons, this has to have 18 electrons. If there's more here, there's 17 protons, there needs to be 18 electrons as well, which is kind of a cool thing. Again, always the electrons that change. That should be able to get you started on some of the questions that we have below. Again, just 5 of them, really quick. Best of luck.